Alright, the Pythagorean theorem and three-dimensional figures. So anything three-dimensional is what we're going to look at in this video. So right here we have a cylinder. So find the diagonal of line segment AC. So this line here. It's the value of x. So that means we're looking for our 90-degree angle. Pythagorean theorem only works with right triangles. And then we got to fill in 8 and 15 are our leg lengths. So 8 squared plus 15 squared gives us c squared, or if you want to use x squared there, because I gave you x. Either way. So 8 squared plus 15 squared gives us 289. To find c, we're then going to take the square root of both sides. Square root of 289 is 17, and that's 17 centimeters. Okay, so find the side length of the cone. So side length is of a cone is from the top here down to the bottom. This is called the height, that straight vertical distance from the center to the top. Side length is that outside edge. So this is what we're trying to find here. So why don't you pause the video and try this one first. Okay, so that means we're trying to find c because it's across our 90-degree angle, or the hypotenuse. So 5.7 and 12 are our legs. So that gives us 176.49 is c squared. Take the square root. Rounding to the nearest tenth here, we get 13.3 centimeters. Alright, find the length of the diagonal of a rectangular prism. So rectangular prisms are pretty common when it comes to the Pythagorean theorem. So if you think about the room, this classroom is a gigantic rectangular prism, and sometimes it's helpful to visualize this image as the classroom. It just might help you figure out what you're trying to solve for. So there are actually two triangles within here. So I've highlighted them for you this time, but sometimes I might not, and I might just give you these measurements. So this blue triangle here represents a triangle on the floor. So this diagonal is the diagonal across the floor of the room. And that's actually the leg length of this yellow triangle. So even though this is the hypotenuse for the triangle on the floor, because even though this doesn't look like 90 degrees in my image, I know where the two floors and my wall meet in a classroom that this is 90 degrees. Okay, so, and then same thing here, this doesn't look like 90 degrees in my image, but I know where a floor and my wall meet forms 90 degrees. So what the problem wants me to find is the diagonal from the top corner of a room to the bottom corner on the opposite side of the room. So this diagonal through the room. So to find that, I need to know these two sides, and I only know one. But I can figure this one out by first solving the blue triangle. So this is my hypotenuse here on the other side. So 3 squared plus 4 squared equals c squared. Solve that out, we're going to figure out that c is 5 centimeters. So, but that was c, this is the hypotenuse for the blue triangle, but it's actually a leg length of the yellow triangle. So then I'm going to have 8 squared plus 5 squared is equal to kind of like my c2 squared, my second c. So 8 squared plus 5 squared gives me 89. Take the square root of 89 to the nearest tenth. we get 9.4 inches. So for this one, we kind of had to do the Pythagorean theorem twice. So we're going to look at a couple examples of the rectangular prism. So here's another one, and I have not labeled my box, my rectangular prism. So I've given you those measurements here. So first step, take a minute and label your rectangular prism. So width of 3 inches. So width is going to be either any of these short sides. So you really only need to label one. So I'm going to label this one as being 3 inches. Height are any of these tall ones. So I'll label this one as being 6 inches. And the length is 10 inches. So any of the lines going straight across here. So what is the biggest pencil I could fit into this box? So that means we are trying to find the diagonal from one corner to the opposite corner. Okay, and this isn't the only way to draw it. You know, there's 4 different diagonals in this room. This is just how I'm drawing it. So that means this is my back wall of my box or room. I always use the room. It just helps me visualize. This is the going through the room, and then I have my diagonal on the floor or diagonal on the base of the box. So this is my first 90-degree angle there. I know that my height here is 6, but I don't know this diagonal on the bottom, which is where my second triangle comes in. Here, which is all on the floor, and my second 90-degree angle. So I know that this is 3, my width, and I know my length here is 10. So I can solve for that first diagonal on the floor. So that's 3 squared plus 10 squared. It's 109. Take the square root of 109. I get 10.4 inches. And so now that's my leg length of my second triangle here. So 6 squared plus 10.4 squared is c squared. Now I know I rounded here, but I know when I square it should bring me right back to 109. And I know 6 squared is 36. So that's how I got a nice 145 here. If you kept it as just 10.4 or a different decimal, you might have a decimal here. So that's kind of how you round during the problem. And then we're going to take the square root of 145, which is 12.0. So just 12 inches is the main diagonal. So I can fit a pencil that is 12 inches long into this box. Okay. So I would like you to pause the video and try this one all on your own. I've already got the diagonals drawn in there for you and the measurements, so it should be a little bit easier. Trying to find the length of this HB here, this blue line. So tricky part might be finding those 90-degree angles. So here's your first one. Okay, we got our first triangle here, so we're trying to find that red diagonal. So that's 5 squared plus 6 squared is equal to c squared. (61). Square root of 61, 7.8. So then here is my second 90-degree angle for this other triangle here. Trying to find this blue diagonal. So it means I have 3 squared plus 7.8 squared, c squared. So 9 plus 61 is 70. Take the square root of 70. You get 8.4 meters, so nearest tenth. So again, depending on how you rounded here, you might be a little bit different than the 8.4, but you should be pretty close. All right, why don't you try one more example all on your own. If you get stuck, play through until you got the help you need and then pause it again to finish it. Give it a try. All right, so I've got a width of 5 centimeters, a length of 7 centimeters, and a height of 8 centimeters. Length of the diagonal on the bottom. So I just want the diagonal on the bottom. So I might have tricked some of you here. So that means I just want the diagonal here. I'm not asking you to do that second diagonal. So here's my 90-degree angle. 5 squared plus 7 squared equals c squared. 74. Take the square root of 74. Get 8.6 centimeters. So I did not even have to use my height there. So make sure you're reading the questions. I didn't ask you for the diagonal of the prism. I asked you for the diagonal on the bottom, not this diagonal. Okay. All right, so let's look at a pyramid. Find the length of the side. So that's this flat side on the outside. The height here is from the center going up. Okay, and I know this is 16. I know this is 24. But I don't know this value here. But I know that this is 16, and this is from the center out, so that means that this is 8. So now we got two sides, 24 and 28 and 8. 24 plus 8 squared is c squared, which is what we're trying to find. So I have 25.3. And I don't have units, so I'm just going to write units. Find the length of the diagonal in the cylinder. So why don't you pause and try this one first. So we're trying to find this length here. So my 90-degree angle's here. So I've got 16 as a leg and 12 as a leg. 400. So 20 inches is the length of this diagonal.